at the notes and the book, everything is available there. So you don't need me to actually draw them again and show you exactly the full details. We already done that, the lecture notes, and all the already available within your book as well. So I'm not going to do that. The only thing I will explain is why do you think these fields were included? Some of them are not being used. We said these are for future usability. They will add few addresses, new control fields. So that's why it's not being used, and that's why it's available as well. Leave it to the future, whoever define those standards. Fine, the question of this one, as we did not do, is the byte stuffing. We explained that the flags itself indicates the beginning and the end of the frames. Sometimes the data come in the same sequence. We say that flags usually are in this type of sequence of bits. 3, 4, 5, I think that's 6 zeros and 6 ones and 2 zeros. Sometimes the data will be identical to those, so we need something called byte stuffing, i.e. adding a sequence of bits very similar to this one, with 5 ones, 0, 1, preceding that data to identify to the receiver that this is actual data, not the flag itself. That's the byte stuffing. Okay? That's with tutorial 1 from the link layer 1. We already practiced sliding window protocol now. Hopefully you practiced it. Hopefully you managed to do the full duplex one. I'm going to provide you now an example of previous year, an exam question. I'm going to ask you to practice it for 10 minutes, and I'll do it afterwards. I'll leave this until then December. I might do another revision. But this is a good chance to just see how the exam questions are. It's available on Blackboard, so if you want to have a look, fair enough. The full details. Well, this is the actual question. Okay, so let's give it attention here. So two sides A and B are connected together. Both sides are a sliding window protocol with a send window size of 3. So what's your window size? That's been defined. First thing you need to define is your window size, and that's 3. We are using go back end. We said we already just using go back end as your error recovery strategy. We're not going to use selective repeat. That's left to layer number 4, which is not going to be implemented within your sliding window protocol. The time interval between the start of the transmission of frame and the completion of the reception at the other side is 1 millisecond. That means if I'm sending a frame at 0 millisecond, arrives at the 1 millisecond. So it requires 1 millisecond to arrive to as a destination. Okay, which we did identical to what we did in the tutorials. Both stuff can react instantly, i.e. they are both full duplex. They both can send and receive. Both sides, receiving frame, a sender will time out if it does not receive an acknowledgement by 5 milliseconds at the latest. So your timer is 5 milliseconds. Your messages are A sending to B are those messages, B sending to A are those messages. So you need to, those are your I messages. I've added the burst of error I told you about. There will be an issue, there will be a noise occurring interval between the 13 and the 14 millisecond. So you need to know exactly where is that happening and what do you do afterwards. Illustrate by means of diagram the flow of frames between A and B, indicate frame types and any sequence of acknowledgement numbers. I'll give you 10 minutes, and I'll do it afterwards, okay?
Is there any way to check it again? Like, is it wrong or not? Like, how we do it in CRC, we can check it, is it right or wrong? Is there any way to check it?
This one?
Yeah. There isn't any way.
You need to just track it. No. You just need to track it. That's the problem. Yeah. There's no way of checking it.
Okay.
Another 5 minutes.
So basically from here, 4, I'd have to do another one, so that's which one?
Okay, I'll do it now. So let's do it together. Yep. This one should go whenever it is. You need to update it. If you don't update it, I can just tell them to read it. It's with the details here. They already update. So what you do eventually, when you do that over, you just do whatever number is here. This bit. If you notice how that but that's right. Let's say you take it as puts 1, which is 1. If it's down, how do you get it? You missed it up here, so it don't make sense what exactly is happening. So stop up here. Right. This is 2. This is 3. This is 0. Okay, I'll do it here. Okay. So don't forget to update your variables. If you don't update your variables, it's hard for you to continue the question. Because I've just seen some of you guys who's doing everything okay, you're putting all the details inside, but the variables is empty. The problem is when you try to put the acknowledgement, you don't know what exactly to put because you say either I reset it, either I put something new, I'm not sure. So just follow the variables themselves. So if you're acknowledging a number, just copy whatever to the receiver, which I'm going to do just in a moment. Try to get closer. So yes, let's follow the messages. As I said, sometimes it's easy if you say the messages from A to B are in those messages, B to A, and you write down the messages. Although you'll have the question in front of you, you'll have an exam question with the paper itself, but it's your call in the end. Put the timer somewhere to indicate to yourself you have a timer of 5 milliseconds, and put the window size to know how many messages you can send. What's left? That's it. Yeah, let's start. So what's the first message from where to where?
0 to 1.
0 to 1. So and if the question says 0, what usually takes 1 millisecond to arrive, it's from A to B. This is A, and this is B. Okay? So what's the first thing you need to do? Is you put the sequence number. Sequence number. You start with the sequence number, and you start with your acknowledgement. That's the only information you put here. Your sequence number are always give it in the question, which I don't think I've given it here. It should be 0, 1, 2, and 3. Then they revolve back to 0. That's the sequence number. There's no other sequence number available. Okay? They don't reset. Be careful. They never reset. They continue. So S equals 0. Acknowledging receiving nothing. You haven't received anything to acknowledge. So it's a 0. So we say a variable of the sender. In this case, is the middle part in here. With the variable of the receiver from this part. Are they equal?
Yes.
Yes. You increment the variable of receiver to 1. You are acknowledging to this side, nothing have been received. And you are incrementing your variable of the sender. Just keep a track. Where am I incrementing the variables? With the sending, I'm incrementing whatever I send. 0 in this case. I'm receiving at 1, I'm incrementing at 1. Okay? Straightforward. What's the next message? 1. So from A to B. That's sent from 1, A to B. Of course, it's sent at 1, it arrives at 2 because it requires 1 millisecond to arrive. S equals?
1.
Acknowledging receiving? Nothing. Nothing had been received. Okay? So is a variable of the sender at the moment 1 equal the variable of the receiver, which is 1? Yes. Yeah. You increment your variable of the receiver to 2. You're still acknowledging 0. And you increment the sender to 2. Just track again where am I incrementing and where am I incrementing to both sides. Until now, everything's clear? Yeah. This should be basic. You should understand that part. Where is the next message coming from and from where to where?
From B to...
We have the same message from A to B. Is that right? We have one coming back at the 2 milliseconds. Send. From here, let's start with this one. You can start with either one you want. Let's do this one first. Give me a sequence number. Of course, those are iframes. Don't forget.
0.
S equals 0. It's not 2. This is a new message. Acknowledging how many?
0. Or 2.
1.
2. Still 0. Again, copy the receiver.
Okay.
That's it. It's not a matter of just predicting it. It's just I've received 2, I acknowledge those 2. Either you say I've received 2 messages, I'm acknowledging 2, or either I say I copy my acknowledgement, my receiver part. Which is very simple. So, is the variable of the sender, in this case is 0, equal the variable of the receiver, which is 0? Yes. I increment my receiver to 1. I'm acknowledging to it, I've received your 2 frames you sent earlier, and I'm incrementing my sender to 1. Again, keep track. I'm incrementing whatever I'm receiving. So I incremented the actual receiver at 3 milliseconds because I received it here. Same message sent back from 2 to arriving to 3. This might be a little bit confusing, so I want you to know the acknowledgement. S equals what? 2. Acknowledging receiving? 0. No, why 3? How much is your receiver at the moment? It's empty, 0. It's the same analogy. If it's a 0, I'll copy it instantly. It's a variable of the sender equal the variable of the receiver. Here, I'm sending this side to this side. So 2 equal 2?
Yeah.
Yep. Increment this to 3. Acknowledging receiving nothing. I increment my sender to 3. Is that clear what happened here? It's not 1 because this have not arrived yet. Of course it's not 3. Yes. Is it?
Yeah, Shabab. Next to 0.
Yeah. Thank you. So is that clear what happened here? Why is this acknowledgement 0, not 3, or 2, or 1?
Because it's 0.
Okay?
Yes, sir.
Everyone, is it clear? Okay. Let's follow the time again. When do I have another message sent? At the 3rd millisecond. From where to where? Sorry, I know. So from A to B, there's a message going. From A to B at the 3rd millisecond. So here is it. From A to B. Tell me the details. S equals? 3. Acknowledging receiving. Now what?
1.
What I'm doing. Just tell me what I'm doing. I'm just copying this as a receiver inside my acknowledgement.
Can I just say something?
Why is it 0? It's 1.
What's the another bit? What's the one number we're sending in there? Is there no 5?
No, there's from A to B 3.
Is there 3?
Yes, at the 3 millisecond.
Yeah.
Okay?
Okay.
Tell me the details now. Is the variable of the sender, I'm sending from this side, equal the variable of the receiver? It is.
Yes.
So go to 0. I'm acknowledging receiving now 1, and I increment my variable of the sender to 0. Okay. I have another message going from B to A at the 5th millisecond. B to A, 5th millisecond. 5 arriving at 6. At the moment, I'm not checking the timer. I'm not checking my window size because it's being covered.
Yeah.
This is the first one I start counting for, this one. So if I count virtually for 1, 2, 3, still time. So 5 milliseconds. I'm not worried. Okay? Tell me the details. S equals?
1.
Acknowledging receiving?
0.
And Y? 1. What is it? Y?
The receiver.
There's no reset. just what the number is. Where are you bringing the 0 from?
And
From the receiver.
is it
From the
0?
receiver side, the variable of receiver. Coming it inside the acknowledgement. So that's 0. That's it. Let's update details. This variable of the sender equal the variable of the receiver. 1 and 1. Yes? I increment my variable of the sender to 2. Increment my receiver to 2. And I'm acknowledging receiving 0. I'm stopping now and jumping to 13 to 14 because after this is just straightforward. We've done the same thing already in the tutorials. The only trick will be the 13 to 14, so I'll just skip that up step. Is that okay? So let's imagine here we have (11, 12, 13, 14). Okay? Let's see the trick now on this side. The first message going is 10 arriving from B to A. First I have an A to B at a 10 millisecond. Let's do the 10 as well. Arriving at the 11. Okay? So first of all, let's assume this is S0 and I'm acknowledging 0. Okay? I have a message going back at the same side from B to A, again at the 10 millisecond. Arriving at the 11. Again, S equals 0, for example, A equals 0. Still nothing changing. I'm not concerned about that at the moment. I just want to see when the error occurs, what happens. A message is going. First of all, let's go back to the question. What does this side say? A burst of noise occurring in interval 13, between 13 and 14. Where is that? In the messages, where is that? Which message is that? 13 to 14. That's the message. So, in other words, this one is not arriving to the destination. So, you need to know where is the error occurring. That's the first part. Because I'm saying between 13 and 14, then it's the 13 one. So you say B arriving, so this side. B sending at the 13, arriving at the 14, did not arrive. Okay? You continue the question, did not arrive. So you don't update this side. You just update whatever you have in this side. And the other message is arriving, 14 to 15. This will have an S equals, for example, 1, and an A equals whatever, 2. In here you'll have S equals 2, A still equals 2. When you try to do that comparison at the moment, this is not updated. So when I say variable of the sender equal to variable of receiver will not be equal, because this went lost.
Is it not resend 13 before it sends 14? Just not resend?
How does it know? This is, now it will know. This will come out of what? Out of order. This is not the right sequence. What will this side do? What will it do?
Reject.
Reject. So it will reject and says that acknowledge only received whatever has been in your receiver inside the acknowledgement. This side will retransmit it again.
But if it's sending from 14 to 15,
Yes.
wouldn't want it count as acknowledgement?
Yes, but it's out of order. Regarding of the acknowledgement, the sequence number are different. Those sequence numbers will not be the same. We are going to compare the both sides. It's not going to be the same. So it will be out of order. You need to reject it.
It times out at 14.
Now I'm not doing the timer at the moment. I'm just following the part where you have an error.
I can't see the bottom there.
Sorry?
I can't see the bottom there.
Can you see it?
Sorry.
Is it better?
Just push it further back.
Okay. Better now?
Yeah.
I can't see it from here. I don't know where you see it from there. The only trick is what I'm trying to say, guys, is if you manage to see a frame out of order, you need to reject it. Even inside the questions, you reject that frame and you close whatever you receive. I hope that's understood. I'm just showing something similar to what I did in the tutorial itself. Yeah, you see, it will be written inside the actual arrow. You say rejection or a negative acknowledgement. You have acknowledgement, which is normal time. But the negative acknowledgement, you just copy the number as well. On the other side, you will know that this is not right. And you'll retransmit whatever you want missing. Hopefully I'll do that in full in our revisions. But at least just give me an idea. Again, practice it, guys. Any questions before I move on?
What happens if it's timeout?
And
It will send again
Of course,
the
you
same.
need to work it out. Times
It
out.
will sense
then-
again.
Yeah, I will not make it that complicated. I'll try to make it with range. Any questions?
So on the exam, you will never access the time a question with the timer.
No, it will time out, but not at the same time as there is an error because
Thank
that will be very. No, I'm not trying to do your favor. It will be very complicated. I try to work it out, but you need to know. You need to track it properly. Okay.
What goes to the reject?
And you put the same as the acknowledgement. How do you put the acknowledgement? You put whatever is received. At the same time, if this got missing, you just put whatever is being received by this side. So let's say you have 1 in here.
Yeah.
And this got missing, so there's no updated details. You just copy that number inside.
Oh, right.
Similar to the receiver part. So you just take whatever's being received, not the parts not being received.
So when B is sending to A, you
Yeah.
copy the receiver of B
Yeah.
to the reject.
Yes.
So is that the acknowledgement? Is that the...
The rejection is similar to the acknowledgement. But when you say reject, you say rejected this frame, whatever frames you arrive, because they are out of order or for any reason, and I received whatever been received. So you're indicating that this frame did not arrive, therefore send me this one and this one again, because you're going to reject those two. Is that right? I'll just show it. So this is how it is. Let's make it very simple. Okay, let's say this is within your question. Okay, you have details here. You have the variable of receiver, you have the sender, and you have your acknowledgement. Let's put numbers for the sake of the numbers. Let's say we have receiver, variable of sender, and then acknowledgement. Let's do the same question, the same part we got missing, but from the beginning. Message is sent from here. Let's say this is 0. This is the same thing. 1 and 2. Let's say a message sent at 0 arriving at 1. This arrived. Okay? So this has 0, acknowledgement 0. Is that right? What do you do? The first thing, you increment this side, you increment, the sending, and you increment the receiver, and then you put 0 here. That's fine. Let's say we have a message going, and then we said there is an error here. So we send this one, an error occurred. Put the details as well. S equals 0, S equals 1, A equals 0. Okay? What do you do? This did not arrive. So this side will update his information because he thought it arrived. So what he will say, you say, variable the sender in here, you will increment your sending to 2, but you'll not increment this one. Is that right? Let's say we have a message saying that 2 arriving to 3. What will be the details here? S equals 2, A equals 0. Is that right? So the first thing you are comparing at the moment is the variable of the sender equal the variable of the receiver at this side? 2 is not equal to 1. There is a problem. This is out of sequence. So this side will reject. This side will reject and says, what did I receive? You tell me.
1.
Only 1. And those 2 will be missing. So this side will retransmit them again. That's it. We'll retransmit those 2 where got missing. One is did not arrive. This will be dropped. Why is being dropped? Because it's out of sequence. That's it. Okay? Okay, we're starting the lecture now, so. You want an early break? No? Okay. Before I go to today's lecture, we did not do the final part of the lecture from last time. We weren't here, so let's see what's this. People are asking, where do I get this information from? We have on the blackboard an ITUT recommendation numbered Q921. It has like a 50 pages or 80 pages, I'm not sure exactly, but there's a part in the middle where it has a sliding window protocol operation. And this is how it looks like. So say, how do I exactly know what's happening? If you follow this, this is exactly what's happening. Look at it for a moment. An I command is sent. If the owner is not busy, then what do? You compare the variable of the sender to the variable of the receiver. You know that part where we are trying to make it equal. If it's equal, then yes, you increment. If it's not, then you need to discard the information because it's out of sequence. Where you need to do either operation, by rejecting or acknowledging. In this case, you need to reject. If it's equal, then you increment and you continue until you reach the part of the acknowledgement. Again, this is very complicated compared to what we try to make here. So, but that's the actual full operation of sliding window protocol. And then again, it's available within your actual backboard within a recommendation Q921. I think it will be more complicated to what I just described, but this is how it's working in full details. Here I'm defining the 3 supervisory frames that we have. They belong to link access protocol bands, which is the type of the protocols available. RR is acknowledging where the receiver can say, I'm receiver ready. I'm happy to accept any parts or any frames coming in from the sender. Receiver not ready is acknowledging I cannot receive any more frames. And we said R and R will not be within your sliding window protocol, just for the own information. Reject is you say that I'm not acknowledging whatever you send, and I'm just telling you that I've received specific frames and these are missing. That's your rejection. These are all supervisory frames, they don't have any sequence number on them. Okay? Okay, so what do we have today? I'm starting today with multiple access protocol. We mentioned that with data link layer protocols, we have a shared medium. Do you know the term broadcasting? Why do you know the term broadcasting? From where? Just network. Where do you have it from? CV. What happened in broadcasting? What do you do? Someone is broadcasting a game. So who is broadcasting? To whom? You have one person broadcasting to multiple persons. So Sky covering a game, covering like how many people have you been subscribed to the sport channel. So that's a one broadcaster to multiple users. In our term of broadcasting, it's not the same. We have multiple users broadcasting to multiple users. Here will become a problem. Because one guy is sending it to everyone, he's controlling the channel. But when you have multiple users and multiple senders, when you send at the same time, imagine this is your actual broadcast channel. And let's say you are sending. So this is A sending a message. Do you know what happened to the actual broadcast? This is how it will be occupied. Everything will be occupied because you are using the full channel. You need to control that because at the same time, if, let's assume B is sending a message. That's a good first example. Let's say it's B sending a message. What will happen here? What's happening? Interference, what means a collision of actual frames. What happens if there's a collision? It drops. If I ask 3 people to speak at the same time, the same thing. Not everyone will understand what's happening. You can understand some of the information, but not everything, because they are speaking at the same time. Where you have a collide of information within the shared channel. The medium now is there. Okay? In this case, what will we require? Multiple access protocol. We need someone to control that channel. So you give other people the priority, or you ask people to wait, or you ask people to do at the same time. That depends on the exact protocol I'm going to use. So I'm now going to describe the 3 types of protocols we are using. Let's first describe in details. First of all, we describe at the moment point-to-point protocol. And what exactly is point-to-point protocol? When you have a one sender and a one receiver, we said there's no shared medium. So in other words, one sender and one receiver will not create any issues because that's being received by one person. Similar to the broadcasting of the TV. One sender to multiple users. That's fine. You are controlling the channel. There's no issues. There will not be collide of information. The collide will happen when you are having a shared medium and more than one user can send information. Either whether that's the same time or not, that's not the case. But when both of you can send information, a collide will happen and then you'll have that drop of packets. So, a broadcast or a shared wire or medium, would like an old-fashioned Ethernet, upstream high-frequency control, or an 802.11 wireless LAN, like a Wi-Fi connection. These are the one you broadcast and have broadcast information. The multi-access protocol required when you have a single shared broadcast channel. 2 or more simultaneous transmission by nodes, interference. Therefore, a collision of nodes receiving the 2 or more signals at the same time will create a collision. Therefore, a drop of packets. As I said, when you are 2 users sending at the same channel, a collide will happen and a drop of packets will appear. It's very simple. The only issue is what do I use of a control protocol and what type of control protocol are available to control that issue and not let it happen again. Multiple access protocols are distributed algorithm that determines how nodes share the channel. So you determine when node can transmit and when it cannot. You communicate about the channel sharing must use the channel itself, so you cannot use a different channel. Same channel must be used by the same users. How does that work? So first of all, what is a channel? We defined it as a bandwidth. And we defined the bandwidth of what? So we said how the bandwidth will work. What are the actual, what did we say? We have a rate of sending. What's that? That's a bit per second. So when I have the rate of the full bandwidth and have one user, how do you define that? One user divided by the full bandwidth. So in other words, one user can use the full bandwidth. No issues. When I start having more than one user, here will happen the issues. Have two users and I'm dividing it on the bandwidth. Here we'll have problems. And again, increase the users, increase the problems as well, because the more you have users, the more chance of colliding information. Because by chance, maybe one of them is idle, another one is using it, there's no problem. Yes?
Isn't it the other way around?
No? That's been divided on the actual channel. Don't worry, it's not mathematical approach, it's just showing exactly how it's been divided by the users. So, that's in medium. Oh, is it the other way around? Sorry. Thank you. That's embarrassing. Okay, so that's being used by the users. Okay? What do you require from your protocols? There are a few criteria you need to understand. You need to know that they should be fully decentralized. So, in other words, they shouldn't be controlled by other people. You shouldn't have a master nodes in a sense, but sometimes you need to have a master node. So it depends on actually what type of protocol I'm using. It should be simple. It should be very simple. When I say simple, it shouldn't be complicated. You don't want to create overhead. You don't want to create a protocol that adds more delay on the network itself. So that should be one of those criteria being used. There are three types. Okay? So 3 types of actual protocols available. First one you'll be very familiar with, where you have a channel partitioning. Where did we do that? Does anyone remember? With circuit switch, what did we use? What was
Divide.
Yeah, that's
Time.
It's a time division,
And
frequency division multiplier. Do you remember that one? These are the actual division between them. So we are dividing the channel into either by time or either by the frequency. We go into details again today. A second type of those, random access. From the name, you give random access to users. Again, you have that collision, but you might have some sort of a detection of collision, a recovery of it. So that's one kind of those partitioning as well. A random access channel is not divided at all and allow collisions. But the whole reason is not allowing collision. The question is, if I allow collision, I should have a recovery from that collision to make other information pass on. Therefore, to recover from collision. That's your random one. Third one, taking turns. So, in other words, I'm having someone telling other people, it's your turn to send information. Now it's your turn. And I'll go into full details of each one of those. Okay? Let's start with channel partitioning. We already described it, and I'm going to describe it again for those who don't understand it. Time division multiplier. What does that mean? Anyone?
Divide by frequency.
No, there are two different things. Dividing by frequency or dividing by time, there are two different things. So when I say time division, what does that mean? So I have the channel. Let's assume the channel is driven in this way. And let's say we have 5 or 6 users. Okay? When I say time division, how am I dividing the actual rate of the actual shared channel?
You divide time.
So depending on the users, you divide them by time. So you take a second and you divide it into a number of seconds. Let's consider it. It depends. It might maybe milliseconds, microseconds, but let's say seconds. And you say we have 4 users, 5 users, 6 users. Okay? Each one of the users will have what? 1 time slot. So let's say we have 6 users. Okay? So I'm given user number 1, that time slot. 2, 3, 4, 5, and 6. So what does that mean? Will there be any collision? You tell me.
No.
No? Why? It's divided. So user number 1 can send information at this stage. He needs to wait 1, 2, 3, 4, 5 seconds until his turn comes back to send information again. But there's no collision whatsoever. But what happened? What are the downside of it? So we achieved, first of all, controlling the channel by giving each one of those users a time slot. Is that right?
Yeah.
So you can send the information whenever it's your turn. So I divided the channel into time parts, or time slots, let's call it. What's the downside of it? Waste. Why? Show me. So let's say we have user number 3. He's sending information. Where is the waste? 2 is not sending anything. So that means even if 2 is not sending, you need to wait all that period to have the chance again to send information. So that's a waste of the actual channel. So therefore it's not very good. You're wasting channel. When will this be useful? You tell me guys. When will this be useful? Will it be ever useful?
Phone, telephone system.
When? What? When will this be useful?
Telephones.
No. Nothing to do with the reliability.
Everyone's trying to send it at the same time.
With what?
Everyone's trying to send the same information at the same time.
You cannot send the same time because you have only a time limit to send. So this is your time.
Yeah, but all the time.
So you mean everyone can send information whenever it's allowed. So in other words, if all of them are occupied and everyone is sending information, therefore there's no wastage. Because everyone can send his type of information whenever it's happening. Then it's working now perfectly. Whenever some of them just, let's say 2 are using it, 1 is using it for Facebook, other one is using it for YouTube. Whenever the person in Facebook just, I'm not bothered anymore, and it went back, then therefore you are wasting bandwidth. That's the downside of it. But when you are both of them using it frequently, regularly, that's fine. Although you're not using the full power of your bandwidth, so if this is 6 megabit per second, you're only using 1 mega because that's defined to you. Is it or is it not? No? Because you're still using the 6, but for 1 second only. You're still using the 6 megabyte, but for 1 second. So in other words, you need to wait and then send. So that's the time division multiplexer. What's the difference with the frequency division multiplexer? Let me read the link first. Let's cover the actual slide. So access to channel in rounds, we said, because you have 1 millisecond or 1 second to use the actual bandwidth. Each station gets fixed length slots, i.e. the length of the packet to transmit the time. Usually they define the slots based on the packet size. So you're allowed to send the full packet in that time slot. Usually they design it in that way. Unused slots go idle, which we said if no one is using it, it'll be a wastage. We'll give an example of 6, we already gave that example. What's the difference between that and the frequency division multiplexer?
Because on the frequency, what's it called? Division meter access, you divide the bandwidth by the number of the user. For example, if the bandwidth
how do
is
you divide the bandwidth? Based on? We said first of all based on time, the first one. The second one?
based on
the frequency itself.
frequency.
So rather than having 6 megabits, you'll have that 1 megabit on the frequency for the whole duration. But again, it's 1 megabit. So in the end, it's the same. Is it? So the same thing happened. Rather than dividing it by time, you are dividing it by the frequency. So therefore, you end up with having only 1 megabit. Yes, plus a second, but it will be the same other time division. Channel spectrum divided into frequency bands. Each station assigned a fixed frequency band. Unused transmission of time, frequency goes idle. Again, the same thing. You have a wastage. If it's everyone using it, then by all means, it's being occupied by all the users. But if any one of those stopped using it, you are wasting the frequency, that part of the rate. That's your channel division. Is that clear? How you are controlling it? Which is we already took it in the actual circuit switch, identical to that one. Is that clear, everyone?
Yeah.
Good. You want a break? You have a 5 minutes break? Yeah? Okay. Yes?